Alright, here's some questions from 11.3, looking at geometric sequences and series. So the first question says, find the sum of this series. So I look at the series, and what I'm looking for, I need a first term, I need a ratio, and I need to know how many terms there are in the sequence. Then I can use this formula, Sn equals A1 1 minus r to the n all over 1 minus r. Okay, A1 first term, that's easy, negative 8. Ratio, fairly easy. I take any term and divide it by the term before it. So 4 divided by negative 8, that'll be negative 1/2. Got it? Number of terms. So 8, 4, 2, and then there's going to be a term, but how many do you go to get to that? Well, you could use another formula, and that formula is this one. An equals a1 r to the n minus 1, and that one has n in it, and I could solve for n. So this term, and I want to know what term that is negative 1 over 32 is equal to the first term is negative 8 times the ratio, which is negative 1/2, raised to the n minus 1. Okay, so I'll first maybe divide both sides by this negative 8. So negative, that'll be positive. So 1 over 32 divided by 8. Let me figure out what that is. 1 over 32 divided by 8. 256. 1 over 256 is equal to negative 1/2 to the n minus 1. Now 256, I think that's a 2. Isn't there a 2 in there somewhere? 2 to the, is it 7th? 2 to the 7th. No, 2 to the 8th. Yeah, so I could rewrite this as negative 1 over 2 to the 8th is equal to negative 1/2 to the n minus 1. And I could say that this is negative 1 over 2 to the 8th is equal to negative 1/2 to the n minus 1. And so the bases are the same, therefore the exponents must be the same. So 8 is equal to n minus 1, therefore n is equal to 9. So it must be the 9th term. So then I can plug that in here. There must be 9 terms. Now I plug things into my formula. The sum of 9 is equal to the first term times 1 minus the ratio, negative 1/2, to the 9th, all over 1 minus the ratio, which is a negative 1/2. And then I just plug that in my calculator to figure out what that comes out to. Let me try that. So negative 1, I'm going to start over here, so I'm going to go negative 1/2 to the 9th equals, and then I'm going to go 1 minus that answer, gives me that. I'll times that by negative 8, gives me that, and then I'll divide that by, in brackets, 1 plus 1/2 equals. So it says negative 171 over 32. I might have done something on the calculator, but I think that would be the correct answer there. Okay, so there's one. Here's another one. Okay, what is the sum of this series? So you have to add things up. Okay, if I want to add things up, I'm going to use this formula. Oh, it's an infinite one. Goes on forever. Oh, so the sum of an infinite series is the first term divided by 1 minus whatever the ratio is. So I don't even know what the first term is. But I could plug this number in, where k is, and figure out the first term. So the first term would be 500 times 1.11 to the negative 1. Let's figure that out. 500 times 1.11 to the negative 1 equals 450.43. So that's my first term, 450.45 divided by 1 minus, the ratio. I need to get a second term. So 500 times 1.11 to the negative 2. Let's figure that out. 500 times 0.11 to the negative 2. Go. That's negative. No, I didn't do 2 then. 500 times 1.11 to the negative 2. That looks better. Not that, would be 405.81. So that's the second term. Now to figure out the ratio, I just take any term, I'll take this one, and divide it by the term before it. 450.45. And it comes out to 0.9009 as the ratio. So I'll put that in right here, 0.9009. So this infinite sum, and I can do that. I can do this infinite sum question because my ratio. I should have done this here. 405.811 divided by 450.45. That's what gives you this number. And so I can find the infinite sum because my ratio is in between 0 and 1. Had that been greater than 1, I couldn't have done this. So if I do it on my calculator, 450.45 minus in brackets 1 minus 0.909 bracket go 451. 451.35. No, my calculator did that wrong. 450.45 divided by, I did subtract before. 1 minus 0.9009 bracket. Go. That looks better. 545.4. So that would be the sum of that infinite geometric series. Let's try another bouncy ball question. Ping pong drop from a height of 16 feet. 16 feet it drops. Ball. And always rebounds a quarter of the distance that it falls. So if it goes up, it's going to go a quarter of 16, which is 4. So it's going to fall 4, and then it'll go up a quarter of that, which is just 1, and then come down to 1, and then it'll go up a quarter of that, or just 1/4, etc. And they say, how high does it rebound the 6th time? So this would be the first rebound, this would be the second rebound. So if they just want to know how high it goes up the 6th time, so, and it's going up, how high does it rebound? So this would be my first term, not the 16. So if I want to know what the 6th term is, my formula is this one, a1r to the n minus 1. First term is 4 times by the ratio is a quarter to the n minus 1. So the 6th time, so this would be 6 minus 1. Or 4 times a quarter to the 5th. So 4 times in brackets a quarter to the 5th. Go 1 over 256. So it's going to come up 1/256th of a foot. In other words, not much at all. And then in letter B, they say find the total sum of the rebound heights. So if I'm looking for a sum, and this one, it probably is assuming it goes on forever. So I would use the sum of an infinite geometric series as this, where the first term, and they want the rebound heights, so that it's starting here, it's not starting at the 16. So the first term is 4 over 1 minus the ratio, it's going up a quarter. So that's going to be 4 over 3/4, or 16 over 3, or 5 1/3. that would be the sum of all of the rebound heights. Okay, I think I have one question. It's an annuity question. This one, first term, they're putting in $3,200. The ratio, because it's going up, the ratio is this percentage plus 1. So it'll be 1.046. That'll be your ratio. And then they want to know, you make a sequence of 10 yearly deposits, so N is 10. And they want to know what the sum of the thing is. So you'd use the sum formula, where you know what A is, you know what R is, and N and R. Plug numbers in, comes up with your answer. Okay, hopefully that helps you out with section 11.3.